Recall that the shape of a frequency curve depends on the distribution of data. In a frequency curve, the data may be distributed with a tail towards the left or right as shown. A frequency curve in which data is evenly distributed around the central value is known as the normally distributed or normal curve. The normal curve is also called the normal probability curve. The data distribution corresponding to a normal probability curve is known as normal distribution. Normal distribution is also known as Gaussian distribution after the mathematician Carl Friedrich Gauss. Many characteristics in nature, including many human characteristics, are normally distributed. For example, the height, weight, and intelligence quotients of adult individuals follow a normal distribution. Let us take one of the characteristics, say the height of adult individuals, and understand how it follows a normal distribution. Let's plot the graph for the height of a female adult population in a region. In this graph, the heights are shown on the horizontal axis and the number of individuals is on the vertical axis. Notice that the maximum number of individuals has the average height of 63 inches. Now, if you look closely, you will notice that nearly the same number of individuals have the heights of 62 and 64 inches. And so is the case with individuals who have the heights of 61 and 65 inches. So roughly, we can say that most individuals in the population are of an average height, and the numbers of individuals below and above the average height are approximately the same. This is the factor that categorizes normal distribution and gives a bell-shaped curve. Note that this may not be true if the height of only a small number of individuals is taken into consideration. Do you think the scores of candidates in a competitive examination are distributed normally? The scores of candidates in a competitive examination are not distributed normally because it may not be true that the score of most candidates are the same as the average score and that an equal number of candidates will have a score less than or more than the average as we go away from the average. In fact, the scores of candidates in a competitive examination may be distributed with a tail towards the right, as maximum number of candidates may have scores less than the average. Let us now determine that the distribution for electricity consumption in a posh locality may correspond to which of these curves. We expect electricity consumption in a posh locality to be higher than the average electricity consumption. Therefore, it will resemble the curve that is distributed towards the left. A normal probability curve possesses some interesting properties. Let's take a look at the properties of a normal probability curve. The shape of a normal probability curve is similar to the shape of a bell. Therefore, it is also known as bell-shaped curve. The normal probability curve is symmetrical about the mean, as 50% of the values lie towards the left of the mean and another 50% lie towards the right of the mean. Further, we know that a median divides the given set of data into two equal parts. Therefore, in such a case, the mean and the median are the same. Recall that the mode of a given set of data is the value that appears most frequently or whose frequency is the highest. In the normal probability curve shown, it is clear that the value at the center is of the highest frequency. Therefore, in this normal probability curve shown, the mode also lies at the center of the curve. Thus, in a normal probability curve, the mean, the median, and the mode coincide with each other. Observe that if the spread of data is more, the curve elongates equally on both sides. And if the spread of data is less, the curve shrinks equally on both sides. We can see that as the mean increases, the normal probability curve shifts towards the right. And as the mean decreases, the normal probability curve shifts towards the left. Observe that although the normal probability curve tapers around both the ends of the x-axis, it never touches the axis. The total area bounded by the normal probability curve and the x-axis is considered as one unit.